Hello, everyone, and thank you for joining us today for our webinar on designing complex stormwater projects, the people, products, and tools used to solve stormwater problems. Before we start today's presentation, we would like to cover a few housekeeping matters that will ensure you have a good experience. We have placed all phones on mute to cut down on background noise and to ensure everyone can hear the presentation. At the conclusion of today's webinar, we will provide information on how to obtain PDH credit for today's presentation. Our webinar today is scheduled to last for 1 hour and will include a question and answer period. If you have a question, please type it in the question box at any time. Our host today is Jeff Smallwood. Jeff is the Stormwater Area Director for the Southeastern United States. Jeff has been with Contech for over 20 years and has a bachelor's degree in civil engineering from Oklahoma State University. He is based out of Orlando, Florida. Now I'll turn the presentation over to Jeff to get us started.
All right, thanks, Jill. Before we start with our panel of presenters, I'd like to point out that while today's webcast has a stormwater management focus, Contech is organized into 3 distinct segments: stormwater, pipe, and structures. We're the nation's largest provider of engineered stormwater, drainage, and prefabricated bridge solutions. We serve all the major markets, commercial, residential, and public infrastructure, and we have over 40 manufacturing facilities across the US. Our team of experts provide consultative guidance from the conceptual design phase all the way through installation. And today's webcast will highlight 8 examples of how we did this on projects within our stormwater segment. As our 4 presenters go through each project, you're going to see the common thread of underground detention. Some examples are going to be standalone applications, while others are combined with stormwater treatment. With this common thread of underground detention, our goal was to make each case study relatable to the broadest audience in the civil design and development industry. Our first presenter is Jelena Vandenhoek. Jelena is a registered professional engineer, and she is Contech's stormwater consultant for King County in Washington State. She's a graduate of Arizona State University with a degree in civil engineering. After spending 6 years with the Arizona Department of Transportation, she started with Contech, where she's excelled in a variety of roles for the past 18 years. Jelena?
Thank you, Jeff, and good morning to everybody from sunny Seattle. Today we have some sunshine. I wanted to start by saying that when I first got invited to participate in this webinar, I wasn't really sure which project I wanted to share with you today, because there's really no such a thing as a cookie cutter project in Pacific Northwest. All of our projects have some unique design challenges, and all of them have some level of complexity. So I ended up picking a couple that not only have interesting solutions, but also show how we at Contech work with our engineering community, and also I will be able to share some of the tools that we utilize in this process. So majority, like Jeff already mentioned, the majority of projects in the Northwest that Contech works on involve some sort of a stormwater treatment. But today we're going to focus strictly on detention systems. The first project that I chose happens to be in Kent, Washington, and really at first sight it seems like a regular underground detention system. There's a parking lot, which is pretty common around here. So at first sight it seems pretty regular and pretty simple. Regulatory around here, it's Washington Department of Ecology allows for the vaults, for the pipes, or for ponds to be utilized for detention. We really rarely utilize ponds because, well, mostly the land is really expensive and nobody really wants a big gaping hole on their project sites. But some of this some of the things that are listed here are pretty much the things I will talk to any engineer about that calls me about needing detention at their job site. What are your site challenges? Do you have any particular design challenges? Footprint? How much vertical space do you have? And in this case, I was very fortunate. This was an engineer that worked with Contech in the past. He worked with our team and he came prepared with all these answers already for us. So this particular project had a high groundwater, which was kind of a big deal, but they have a lot of depth, which is also kind of unusual. They had close to 20 feet from top grade to the outlet. They were going to pump in, so the depth wasn't necessarily the issue, but they also had some existing utilities that they're trying to work around, and they also need to meet outrigger loading, which is pretty common, and we can always accommodate it. This engineer already ran their modeling and came up with a storage, so it was all presented to us. We were fortunate that he already prepared the original conceptual design, and he utilized 144-inch aluminized corrugated metal pipe for his original solution. So I'm going to take a moment and just discuss why did he go with corrugated metal pipe. We do have many products at Contech. This is certainly not the only one, but we are very lucky to have a local CMP plant in Arlington, which is about an hour north of Seattle. So usually if corrugated metal pipe is a good solution for your project, it ends up being very economical and very cost effective. It's also very nice to be able to contribute to the local economy, utilize local workforce, and it's also excellent for environment, which is something that's very special to us at Contech because it shortens the truck trips and it saves on fuel, which is even more important now that fuel prices are kind of escalating. So as I mentioned, this engineer, since he worked with us before, this was his first go-to solution. However, he did have some concerns, and as I mentioned, that there was existing groundwater at the project, and he was hoping to get it a little bit shallower than 144-inch. You got to remember that 144-inch looks perfect on site. It fits nicely in the footprint between his utilities, but as you can tell, this pipe can get really, really large really quickly. So we looked at some other options. We started with 120-inch option and 96-inch option, but not surprisingly, once you go smaller in diameter, what ends up happening, you start increasing the footprint. So that was kind of colliding with the other requirements for the project. So we had to look and think a little bit outside of the box, and we ended up looking at 120-inch perforated pipe. And what allowed us to do this is utilizing perforated pipe plus 40% porous rock. So some of the volume would be stored in a pipe and some would be stored in a rock around it. The whole system would then be wrapped in the impermeable liner. Super quickly, I'm not going to spend much time on this, but this snapshot that you see is our DYOD, which is Design Your Own Detention. It is on our website. It's free and available for everybody to use. And we heavily use it in our area in Pacific Northwest. If you haven't had a chance to try it, please do. You will not regret it. If you're not sure how to get there, drop us a note in a chat and we'll make sure that somebody sends you a link. It's a wonderful tool. If you have your footprint and a depth, it will give you all kinds of different opportunities to find different solutions. So back to my project, after we decided that this 120-inch fit nicely, it pretty closely matched the original 144-inch solid corrugated metal pipe. From there on, we will develop the specific shop drawings, which look very similar to the original drawing, but we'll have more details. We'll have specific lengths. It will have, risers, inlet and outlet pipes. So from here, these shop drawings will get approved. They will go to the shop. They will get manufactured, delivered to the job site. And this is what that looks like. So you will notice the black liner that's placed first, corrugated metal pipe, some rock around it, risers. I will say that all our end caps are structurally checked and reinforced. And then this is probably one of my favorite views is from the inside of the fully perforated corrugated metal pipe. So my second project was actually very different. It was actually kind of the opposite of the first one. While we had a lot of cover on the first side, we had almost no cover on this one. It was just entirely different challenge. It was also not much room in this project to create for detention in general. If you look at it, the most of the project was taken by building pad and the flood storage underneath. So we really had to scramble to find some detention, room for detention all the way around this building. And there really wasn't much. Also, another challenge was, like I said, at some spots, there was only like 12 inches of minimum height of cover. So, you know, it limited our options. So we went back and forth with the engineer. Fortunately, another very experienced engineer with us. So we had a constant communication about what options we would use. We tried 42-inch diameter pipe. That's about how much room we had to work with. And actually ended up using arch pipe. And the reason why is you can see if comparing the two profiles and the area that it provides, arch pipe allowed us to maximize the volume and minimize the footprint, which was very important for this project. Just like in the previous project, these would be the shop drawings. You can see we always scraped like every little piece that we can find to make this detention work, and it worked beautifully. It has risers. Again, this would go to the shop. It would get manufactured and delivered to the job site. Another interesting part of this project, which is kind of unusual for us a little bit, I don't see it at least much in my territory, is this flood storage. They were hoping to remove some of the sediment prior to sending it to the rock section that was storing the flood. And so they utilized one of our hydrodynamic separators. We have several of them that are approved by the Department of Ecology, and that was Vortex 1000. And this is just how it looked delivered to the job site. On your right, it's our Vortex units, and on the left, you can see arched pipe with some risers sitting on a job site ready to install. And lastly, this is like my favorite slide. Some of you recognize Doug Maxwell. He has been a Contech employee for 30 plus years, and he is really famous in this area for providing incredible and dedicated customer service. Here you can see Doug with a snorkel mask. He's troubleshooting and problem solving on some very old piece of corrugated metal pipe. So it just made me laugh, and I wanted to see I am very dedicated to my customers, but you probably won't catch me doing quite this. But my team and I at Contech are dedicated to the following. Definitely communication, a lot of communication and a frequent communication throughout the process. Flexibility, we are very open-minded and we're flexible to try every product out there and to help the engineer find a perfect solution for their specific project. And we do believe that every project is possible, every project is doable, and it's important to put our heads together and find what works the best for all of us. And that's all I had. Thank you so much for listening to me. I am going to send it over to Jeff, but I will say if there is any questions or comments about anything I've said or didn't say, please again drop them in the chat and we will make sure that somebody gets back to you. Thanks again.
All right, thanks, Jelena. Definitely two different projects that show our versatility. And one thing I wanted to point out on that first project that Jelena showed with the large diameter 120-inch, you may have remembered it had a full-size header piece or manifold on one end. And what we do a lot of times now, which you may see us recommend, is not a full-size, but a smaller size manifold or header piece than the actual barrel length, because we can make those faster, more efficiently, and get them shipped on a truck more efficiently as well. So you will see that from time to time as well in our proposals. Next, we'll be hearing from Josh Stackhouse. Josh is one of Contech's stormwater consultants serving the New England states. He brings over 17 years of stormwater engineering experience to the clients in his geography. He has a degree in technology management with a focus in industrial management from the University of Southern Maine. Josh?
Thanks, Jeff. So for my two projects today, I'm going to start with one called 124 Technology Parkway. That's the official name. It's in South Burlington, Vermont. I'm actually calling the project Making the Elevations Work, and you'll see why here in a moment. So if you look at the photo on my screen, you'll see the blue rectangle, which is actually that's the construction limits. It's really what we're trying to work within. All we're doing is adding additional parking at this site. The red rectangle that you see inside that ultimately is going to become a detention system. You can see it's currently a pond. And for this particular project, from a regulatory standpoint, the engineer needed to meet what Vermont terms as a tier 2 treatment practice, meaning that in order to redevelop this site, they needed to remove 60% phosphorus. And the site challenge that I mentioned in making the elevation work is that they only had 5.5 feet to work with from what was the proposed finished grade to the outfall. And then from there, it was a fairly straightforward design. The engineer reached out to Contech. We have numerous products that are approved for that tier 2 specification. And so I initially looked at a flow through practice. That was the intent, is something just grabs the water, treats it, and then discharges. It actually goes to a wetland off there to the left. And when doing so, we determined rather quickly that treating this particular area was going to be a little bit more expensive than the client had envisioned. And I proposed, well, what if we store the water instead, kind of attenuate that peak in that hydrograph and discharge at a lower rate over a longer period, and maybe use a storm filter instead. And ultimately, there was some waffling on whether that was the right way to go until the price came in at about 40% less. And ultimately, that was the direction we moved forward with. And so if you look at my screen right now, you'll see the detention system here, kind of in the center. And you can see an inlet, I think where my cursor is showing here in the lower right-hand corner, making sure that the audience can see my view. So there is a inlet pipes on the bottom edge, both from the right-hand side and this page south, and discharging off to the left to the storm filter. There we go, I think the screen got up. So the storm filter requires activation head, and we have to build that head somehow. Normally that's done via elevations. In this case, because it was so shallow, the main line of the detention system was the same elevation as the inlet into the storm filter. The challenge in that is we still have to generate activation head. Once the storm filters once there's enough flow coming around the cartridges that the filter essentially kicks on, if you will, it's a siphon at that point. And so it will draw down the upstream water volume, but you just need to activate. So my intention was to fill the first row and then activate the storm filter with that, and then spill over that blue line that you can see in the middle of my screen. That's a weir. And so once it spills over, then you can capture the rest of the water quality volume. Therefore, you don't have to wait until the full storm before the storm filter starts to work. So there's nothing unique about a weir. It happens in many detention systems. It's just, how do you get it to drain back down? Common logic is using something like a small orifice at the bottom. And we can certainly do that. But I was concerned about clogging. Unless it's a large enough orifice that you don't have that issue, the challenge becomes maintaining them. So I proposed a one-way check valve. And by locating this valve at the bottom of the weir, that allowed the first barrel to fill up, spill or discharge into the storm filter, and then spill over the wall into the remaining barrels. As the storm filter is pulling water in and it drains that first barrel, the valve opens back up and it allows the whole system to effectively drain down at the end of the storm. Sort of a simple solution, but was one that we hadn't done yet within Contech. We use this valve in another detention product extension called Void Saver, but we've never used it inside to control flow. So this was kind of an elegant solution to a challenge that we hadn't really run into before. And so you'll see, here on my next slide, I don't know that it's popped up for you guys yet, but there is a site install. The contractor is actually standing on top of the detention system, peeking out. The system itself, the detention, arrived on site about a week and a half before the storm filter did. And because the contractor was familiar with it, went ahead and just installed the entire system before the storm filter arrived, which subsequently made things very simple and easy on site for the storm filter install, because they had a place already prepped for it, as you can see here. And that certainly made finishing up the construction a much less challenging situation because they were ready to roll. And in the last photo for this particular project, which I know is still not up on your screen yet, you'll see some foreground asphalt, which ends up being the finished product for the existing. And then behind that, you'll see the new asphalt. To the left side, if you look left at the utility pole, you can actually see the grade elevation change between the existing parking and the new. Because it was so shallow, they actually raised the grade slightly in that area just to make sure there was a minimum cover, which is only 12 inches for CNP, but allowed them to kind of meet those grading requirements. And you got to love a Google view for a street view in late November in Vermont. It's not normally this nice. And so moving on to my next project, this is called Catania Spania Corp. And this is a cooking oils manufacturer. It's in Ayer, Massachusetts. And they needed to basically put an addition on the side of the building. That was their goal, just to do an extension. Their only real challenge from a regulatory standpoint, the Mass DEP didn't require them to do anything unique, really just capturing and treating the water quality volume. However, to put the building addition where they had space available, there was an existing stormwater pond that was treating 34 acres of off-site area. And so it was a sizable pond, and unfortunately, like I said, that's where the building needed to go. The engineer proposed putting a detention system kind of between the loading docks, where you can see in the photo here on the slide, between the loading docks and the trailer storage area. And then the customer came back with a notation that we need to keep this facility open during construction. So anything that blocks the loading bay is certainly that's out of the question. And so I decided to title this project "Working with Existing Features" because the engineer noted the area to the upper right in the photo that you can see. There's actually a depression there. That was an existing infiltration basin or a dry pond that was treating the on-site runoff. And so they decided, let's just make that area bigger. Maybe we can expand it and capture everything that's coming from the other side of the building will be rerouted to that location. And so they reached out to Contech and said, what can we do with this that allows us to use the existing topography without excavating more than necessary to try to minimize overall cost for the entire construction. And so what we worked with was multiple diameters. We looked at initially 72-inch, and then we looked at a 24-foot con span using one large basin with 60-inch pipes at a higher elevation to connect back over. We looked at 120-inch, I think we looked at 108-inch if memory serves, ultimately landing on 96-inch. And in this case, as Yelena was just mentioning, sometimes you can go big, sometimes you can find the middle ground if you're using perforated. It's exactly what we decided to do in this case. By using perforated pipe, we were able to use the stone around the detention system as well, and was able to make the system kind of long and skinny, allowing for a driveway access during construction. And it was also, it reduced shipping costs. The nearby plant was only about 70 miles away, but it still wasn't a permitted load, which allowed them to kind of save in those trucking costs. So when you're looking at this final site plan here, you can see the existing building, the new building in the upper left, that was the whole pond before. So everything from that side, as I mentioned, comes down now to this detention system. And you can see the little blue circles kicking around there. Those were Cascade or CDS units being used for pretreatment. Contech worked very closely with the engineer on this particular project. We were on webinars, or excuse me, on Teams meetings through this process, working with the installation consultant that was part of the project, as well as the contractor, on-site field visits. It really was almost like a design build team trying to find the best, lowest cost option that really met the owner's needs and satisfied all the requirements. And we finally arrived at this 96-inch system that I mentioned that was intended to be both perforated and solid, and perforated at that lower right-hand corner where the infiltration basin was, and then leaving it solid above, but still using stone around it and having a membrane underneath directing water down to that infiltration field. Ultimately, we ended up with fully perforated system all the way up to the manifold, which you will see here in my next photo. The manifold, by doing that with solid, we had that coil on hand. And last summer, we started seeing production delays with different material availability. We were able to meet the timeline because we already had the coil on hand. And so by us building the coil, with us building that manifold first, we could get that to the site before the perforated coil came in, and thus getting the contractor started that much sooner, which was certainly helpful for the contractor in general. And as you might see those last three barrels kind of coming out high, those three stubs, those are for the 50-year event, really looking at a spillway that went to a riprap channel that actually ultimately ended up inside a wetland area. And then there is a nice aerial view here where you see basically the entire system is in, minus a couple of pieces. There's still a couple of pieces left to be installed, and a little bit more stone to put in. But this was kind of wrapping things up at the end of the construction season last year, kind of highlighting how nicely these things can go in with a little bit of care taken and the forethought on the front end. And you can still see the trailers moving in the upper left in the corner. That the site never did shut down. There was trucks rolling through all day, every day. And so for myself, my key takeaways here are really early engagement. Both of these projects were a little bit iterative, working very closely with the engineer back and forth, trying to find the right way to solve the challenge. Contech has a lot of experience in doing that. We certainly have approaches that translate every time, and there's certain ones that are definitely one-offs. We're good if you can use a little bit of time in the front to think about it. That's not to say we can't be reactive, and I think Dana's going to talk about that here coming up. It helps if you've got extra time, but even if you don't, we're very good at reacting to whatever needs you may have. And with that, I will pass it back to Jeff.
All right, thanks, Josh. One thing that I wanted to point out about Josh's first project that had the 42-inch system on it, you've heard both Jelena and Josh talk about the importance of maximizing the headroom available for an underground detention system. That's how you're going to get the most cost-effective system. But when elevations don't allow, and you've got to use a smaller system, then we can go down to those smaller diameters. But we're not limited to just every 6-inch increments like most pipes that you're used to. We can do 1-inch increments if it had to be a 44 or a 45. So we can maximize every inch of that headroom on your site. So our next presenter is Dana Heineman. Dana is the stormwater consultant for Ohio and Kentucky. She started with Contech in 2016. And after graduating from Valparaiso University with a degree in civil engineering, and she's been excelling at providing the most innovative and cost-effective stormwater solutions to engineers and regulators ever since. Dana?
Awesome, thanks, Jeff. I think everyone can see my screen. I think it just finally popped up here, but thanks for joining us today. It's a little overcast up here in Columbus, Ohio, but thank you for taking some time this afternoon to sit down and learn about a couple of these projects. So the two projects that I was going to talk about, as Josh mentioned, if you can get us involved early, that does help kind of alleviate some headaches later on down the road, especially since a lot of these designs are quite iterative. That being said, we can do reactive work. And so a lot of the projects that I was working on were, kind of more reactive on the tail end of things. So with the projects, the first one I'm going to talk about is iVisionary. That was the name for us. It was in Ohio, but as Josh had some fun little titles for his project, so do I. So can we get it quick? That really is what it all boiled down to with this project. The regulatory requirements for it, they were replacing an existing basin. On this site, it was a logistics center to ship out, different freight trucks, things of that nature. So our regulatory requirements were we did have to abide by the OEPA Phase 2 construction general permit. And with that, since we were replacing an existing basin, it was almost a one-to-one swap. So the storage that we had to store was about 60,000 cubic feet. And then with any type of underground detention that we're working with in Ohio, most of the time we need to pre-treat that with some sort of hydrodynamic separator. And so we needed 8 CFS of treatment flow rate to be treated for this project. So lead time was a really big concern for this project. They had reached out to a couple other suppliers. We kind of got brought on towards the middle of this project. It was a design build. And so with that, other suppliers were out 4 to 5 months, and we were currently looking at a 4 to 6 week lead time after approved drawings. So we definitely could get this turned around quite quick. It was a generally large site. Again, we were replacing an existing basin. And then since we were doing that, we wanted to make sure we were maximizing the total depth available on site. So what we decided to take a look at is a couple different layouts. So since this was such a quick turnaround time, a lot of moving parts for this project, I ended up using our online detention tool, so our DYODS in our Contech Design Center. As Yelena mentioned, this is a great tool to utilize when you're looking at some layouts. So we got that turned around within 2 days, looking at 3 different alternatives: a 48-inch, a 60-inch, and a 96-inch perforated CMP system. We were going to try and use the stone voids to, again, shrink that overall footprint size and really maximize how much depth and storage we could get within that given footprint. So just some takeaways from that online tool. This is internal, we use this, and then it's also external. So this is, clients can take a look at this if you are working on anything, looking at preliminary designs, want to see how much pipe you would need to fit a certain storage volume or a certain footprint. You yourselves can actually go in there and work with this tool and get drawings same day into your inbox. So I use this quite a lot. It's very, very quick and easy. Again, if you're looking for these quick design projects, looking at a bunch of different alternatives, the DYODS and the Contech Design Center are quite useful within those projects. So what we ended up kind of landing on for this system was actually 120-inch. So we increased it from 96-inch up to 120-inch using an exfiltration joint. So with lead times, our perforated lead times were a little bit higher than our solid walled at this time of this project. And so we really needed to make sure we got something to site as quick as possible. So with the exfiltration joint, it's a solid walled system. And it's basically a gap joint that allows for water to flow in and out of the stone. So we can utilize the stone void space on these systems. So it functions similarly to a perforated CMP system. It just looks a little bit different. So by utilizing that, cutting down on some of those lead times, again, using those stone voids to shrink the overall footprint size. And then for that final design, I think initial reach out from the client was May 28th, and we had everything done and finalized with the design by June 17th. So very, very quick turnaround. We were able to get submittals together and then start with that approval process and getting those manufactured. So nice little aerial view. This site was actually close to our corporate office, so we got to get some aerial views on this. As you can see, that 120-inch pipe kind of laying there ready to be installed. Also at the bottom of the page, we do have our cascade. So again, we did need to use treatment for those regulatory requirements, and so we ended up on a Cascade 10 to treat that 8 CFS. Another nice little aerial photo, as you can see them prepping the basin to lay down the CMP. Again, stone bedding to lay down that CMP. Also, with that, we did have to help with the installation of the CS unit, so the CDF or the Cascade 10. So with our larger systems, we do need to have some field installation assistance for those. They do come shipped in pieces. And so we will provide a Contech field rep to assist with the assembly of that larger Cascade unit. So you can see them kind of assembling that throughout the 3 photos that we have on the screen, and then them dropping those internals down into that Cascade. So some key takeaways for this project. Again, turnaround time really was #1. Getting that design together quickly, getting submittals approved quickly, and getting it to site quickly. It was a quick turnaround time, which we were able to assist with on that. We also had some installation assistance as well. Since this was a 120-inch pipe with an exfiltration joint, we did have pre-cons. Our field team was able to assist the contractor with any questions that they might have had on the CMP installation. And then for the Cascade, since it was that large unit, the 10-foot unit, we did have the Contech field installation team out to assist the contractor with that assembly. Additionally, a nice little takeaway, since it was local, this was actually close to Contech's headquarters in Westchester, Ohio. So it did serve as an educational experience for our internal team. So our internal support team, we had our stormwater design engineers out there who help with getting the drawings together, the proposals, the submittals for these systems. Our project coordinator was able to come visit, who helps with the contractor actually getting that timing down, when it's going to be delivered, any of those little nuances for delivery. And then our internal sales coordinator team. So actually the team that helps put orders in, get everything ordered and ready. So kind of all of the support that goes behind these projects outside of, you know, myself working with the engineer. We do have a whole team, and they were able to go out, take a photo inside some big pipe, and see that installation. So thank you to Wood Group, who is the contractor on that, for allowing them to be out on site for that project. Next, and my final project that we wanted to highlight was French Quarter Square. So it's not a rectangle. We like to see rectangular systems just because they do tend to optimize, especially if we can make longer runs of pipe. It helps to make a more economical system layout. But we do recognize that that's not always the case. Every site's different. Every layout's going to be different for these systems. So what can we do to help assist with that? So regulatory requirements for this project, local requirements, we did have to store our flood control, but treatment was actually accounted for in a regional basin. So we did not need to have any sort of water quality, a hydrodynamic separator. We did not need to have that, since we were strictly just looking at detention volume. Some of the site challenges, is pretty much a moving target the entire time we were working with the engineer on this project. So it was close to a gas station. There was going to also be an additional gas station built near the site. So curbs, light poles, buildings, water lines, you name it, we had to go around some sort of obstacle. So a lot of iterations that were done with this project, and that storage volume was about 70,600 cubic feet of storage. So just some of the designs that we had looked at. So the engineer of record actually had put most of these designs together. So another instance of us kind of just being brought in after, you know, a solution has essentially been selected. We were there to really work with the engineer as they were putting these layouts together, just to make sure that any design constraints, any manufacturing constraints that we might have had with CMP, were being accounted for with these projects. So a lot of different layouts, but what we finally landed on were these two details on the right. So it was two separate systems that eventually connected for our detention storage. So some takeaways for this: again, the engineer of record really did a lot of this design work, which we're happy to assist with, but they put those preliminary layouts together, again, going back and forth, confirming those designs, making sure there were no red flags. And then we ended up going with 72-inch perforated CMP, utilizing those stones voids for storage. So again, if we can get involved early on with these projects, that's great. We can do a lot of this troubleshooting at the beginning, but a lot of the time there are moving targets, things that we as Contech don't see, but you as the engineer are working around. So just have a conversation with us. We'd be more than happy to review anything that you might already have together, and just kind of that back and forth really is helpful when looking at these projects. So just some site photos to kind of wrap up here. As you can see, this was kind of the stair-step version or portion of that detention system. 72-inch perf CMP, you can see a riser, a nice shot of the bulkhead at the end of that top row. And then, as mentioned, kind of that stair-step application. So we were able to go out on site, again, assist with any questions that the contractor might have had, but everything did end up going relatively smoothly after we had selected that system design. But that being said, if you have questions, again, type those into the chat, but I am done with my portion, so I will turn it back over to Jeff.
All right, thanks, Dana. You know, one thing I wanted to add, in addition to all of the things that we did on Dana's first project example to pivot and meet the timeline requirement for that client, was, you know, in addition to the material pivots, going from a solid to from a perf to a solid and getting that thing turned around, additionally, we have the ability to use over 40 plants across the US. So that's, as I mentioned at the beginning, that's a huge advantage that we have to provide the best and fastest service for these projects. If one plant is booked up pretty solid, we can quickly shift to another. So our final presenter is Chris Lant. Chris is one of Contech's Florida-based stormwater consultants. Chris has served the stormwater industry with over 25 years of design and permitting experience across the US and Canada. He's degreed in construction management and environmental engineering from the University of Florida. Chris's ability to creatively and expertly solve complex stormwater problems will be displayed in these two projects that he'll be highlighting today. Chris?
Thank you, Jeff. So I'm just going to briefly go over and highlight some of Contech's successful track record in working on large, complex infrastructure projects. Many of these projects are design builds, and Contech brings two capabilities to the table for these type of projects. Number one, we have a comprehensive group of product solutions that will solve any storage issue or treatment issue when it comes to designing stormwater systems. And number two, we have a deep design experience backing up all of those solutions. We're not just a product manufacturing providing company. We back up everything we do with engineering and design services for those projects. And a good example of that type of a project is a third cruise terminal that was recently completed out at Port Canaveral. Port Canaveral is on the east coast of Florida. It's a very dynamic port facility. SpaceX operates out of this port. So when you see the boosters land on the barges out in the Atlantic Ocean, they bring those barges in at this port. There's a US Navy submarine based here, and there's a large fishing, cargo, and cruise fleet. And Contech's part in this project was to design 3 large exfiltration systems at this port. And a challenge for the overall team was to maintain active use of the facilities that were out here during construction. And if you've ever worked on a project of this type, you'll realize that there's a fairly complex project management and design structure, which is not overall very difficult, except that one of the tightest situations that we needed to manage for this project was that the schedule for the docking of the first boat at this cruise terminal had already been set before the design for the project was undertaken and completed. So everyone was trying to manage around that timeline. So this is just the larger layout that we did for this port facility. I'm not going to go into each technical detail about the way we did this design, but just for scale, each one of the red rectangles here in this layout is one section of our concrete product called Terry Arch that measures about 8 by 20 feet. So I think we manufactured and delivered about 650 Terry Arch units for this project. There's a good overhead view of the layout. And as always, there are design challenges for every project. One of the larger ones that we had to contend with here was we had less than desirable soils. As always, we had a limited vertical space to put storage into and to make that storage work with the required hydraulic controls. There's always conflicting utilities on every site that you may work on, but because this was a design build project, many of the utilities that we had to work around were being designed concurrent to our system. So while everything was being designed at once, we needed to ensure we had some flexibility in our design to allow changes in the other utilities without delaying the overall project schedule. The Port Authority was requiring a concrete solution, which we could offer. And then again, because of the number of design engineers, general contractors, and other participants in this project, the normal system for approving designs was more complex than it would be on a normal project. And so that timeline that I talked about earlier was always on everybody's mind, and we were trying to find ways to speed the process along. So on the soils challenges, the geotechnical issues that we encountered were due to how the port was developed over time. In the photo here on the left, you can see what the port looked like in the 1950s. The standards for backfilling and creating a facility like this back in those days were not what they are today. And the result was in the project area, which is highlighted in the yellow box here, we didn't have the best soils. They didn't provide the soil bearing capacity that we wanted to see for our product. So Contech worked directly with the geotechnical engineer for this project to overcome that less than desired soil bearing capacity so that we could design a foundation that was going to work with the existing soils and work with our product to support the loading that was going to be going over the top of it. You know, there was no time to consider over excavating, removing all the soil and then replacing it, much less the expense of doing so. A second design challenge we had to overcome was the hydraulics of the overall design in the storage system. We typically in Florida on the coast especially have a very narrow vertical profile to work with, but in addition to that, on this project at a port, we had limited ability to control the finished grade elevations and therefore the hydraulic controls. So we had to take the engineer's drainage system design and hydraulic control design and ensure that we could adapt a concrete solution, since that was what was preferred by the port, into those elevations, which we were able to do. Now I'll go back to utility design coordination. Again, this was a design build project. We had landscaping plans, we had light pole plans, we had electrical conduits, irrigation, water, sewer, fire mains, everything that was out there that was going to have to be installed was being designed concurrent to our system. So we had to find a way to design flexibility into our system to allow those systems to change without impacting our design, because it needed to move forward to make sure that we were going to hit the overall project timeline. So these rectangles represent future locations of light pole foundations. What we had to do was spread out parts of our system to create a corridor, if you will, to allow utilities to be ultimately constructed there, but to allow enough space so that the design of those utilities could be flexible and they could move landscape islands around, they could move light pole foundations around, and no matter what they did, we could keep our system in place the way we were designing it and go forward with permitting. So where those red rectangles are, you can see the black cylinders in the photo, which was where the light pole foundations ended up going in. I know that those shifted back and forth during design, but again, we ensured we had flexibility so we didn't hold up any of the timeline. And in the end, we ended up with a very cost-efficient, space-efficient concrete solution that satisfied the Port Authority. Everything went in on time. There's always challenges during construction that can delay things, but we worked around those, and we're very proud to be a part of this project. Now, second large infrastructure project that we participated in, that I participated in, was the I-4 Ultimate Project. At one point in time, I believe this was the largest public infrastructure project that was ongoing in the nation. I-4 is a highway that cuts straight through the heart of downtown Orlando. It was an expansion of the existing highway. So you can imagine the effect on the pre-existing stormwater systems and how an expansion of a highway in an urbanized environment created some complication in figuring out how to replace those facilities and adapt them to taking on the extra stormwater volume that was generated by the expansion of the highway. So we ended up with 7 CMP stormwater exfiltration systems that we designed, 2 Duramax detention systems that were actually designed to be constructed within the water table, a solid wall CMP detention system, 7 filtration systems that were designed to remove phosphorus and nitrogen to allow discharge through some newly created outfalls. And then we had to design and install 2 hydrodynamic separators to treat 2 pre-existing outfalls that needed to be upgraded. So I mentioned earlier in the presentation how one of Contech's strengths is that we have a broad product toolbox to work with, and this project was a perfect example of that. We could satisfy all the different needs on the project from one toolbox. We just needed to design with these different products in mind. And our participation in the project actually started before the contract was awarded to the design build teams. The early part of this project was designed 10 years prior, just for permitting purposes, and it wasn't the most cost-efficient design. In the yellow triangle at the top of the layout here, what we saw on a lot of the project locations were large cast-in-place underground concrete vaults that were going to be utilized as giant sand filters. They were going to have a 3-foot layer of sand in the base of them with an underdrain system, And they weren't only going to be costly to manufacture and install, they were going to be costly to maintain over time. So one of the first things that we did was we did some value engineering on the project at these locations, and we presented some engineering proposals, some value engineering proposals to the design build teams. And then after the design build team was chosen, we refined those proposals to help them save more space and costs on the project. And we ended up with a collection of the different systems I mentioned, because you can imagine a large highway cutting through an urbanized area, and what you're left with in the right of way between the roadway and private property is where you have to put your stormwater management facilities. You have no more space to use other than that. And so in some locations, we're able to use our variable diameter strategy that Jeff mentioned earlier to ensure that we were optimizing the use of space. So we used a lot of traditional CMP exfiltration systems between the roadway and the right-of-way line, which you see in these photos. In two locations, the areas that we were given were not large enough to construct the required water quality and attenuation volumes. And so we had to come up with some unique solutions to satisfy the permitting requirements. And one of those was finding a way to construct stormwater storage within the water table. The only way to do that is to use a watertight system. And we have our Duramax pipe, which, because it was originally designed for the sanitary sewer market, has a very high pressure rated joint system. And so that allowed us to put stormwater storage into the water table and keep the stormwater volume within the pipe prior to discharge, but more importantly, keep the groundwater from coming into the pipe and using up the storage volume and not allowing the storage volume to be there to take runoff from the roadway. Another view of one of the Duramax systems, we had a 72-inch system and a 96-inch Duramax system on this project. At several of the locations, we were required to treat the discharge to remove over 80% of the phosphorus and over 50% of the nitrogen that was going to be released into some urban recreational lakes downtown. So instead of using the sand layer in those originally designed cast-in-place concrete vaults, we used a traditional detention system, and downstream of those detention systems, we put storm filters in to remove the nutrients. So the footprint for the filtration requirement for this project went down dramatically, and the maintenance, more importantly, got much simpler. The design build teams on this project have to maintain the systems that are installed for the next 40 years. So the efficiency of maintenance was very important to these teams, and it was a prime part of our proposal to them. And then here's the location of the filters downstream of detention, and a photo of them going in. And then lastly, we had two large outfalls that needed to be upgraded. But when this highway was originally constructed, there were numerous outfalls that had never been treated before. We needed to, as a consequence of upgrading the size of those systems and increasing the discharge rate, we needed to provide treatment there. And we have a large suite of hydrodynamic separator products. One of the most capable ones is the CDS unit. Treats very large flow rates. And typically when you're in an urbanized environment like this one, when you're upgrading a pipe and you're increasing the impervious surface area, your flow rates also go up dramatically. So we needed to utilize a couple of these units to provide meaningful treatment to these outfalls, and helped the engineering team get the required permits on these outfalls as well as the filtration ones. Now, one capability that Contech has that we did not use on this project that was shown in the intro video to this presentation is the mobile pipe mill. On some large projects where we have a large quantity of CMP pipe to provide, we will take a mobile mill, we'll locate it on site, and it allows us to manufacture the materials that we're going to be using on that site without the need to have multiple trucks delivering already manufactured pipe. So it allows us to reduce maintenance of traffic, reduce shipping costs, and basically manufacture material as it's needed and as it is installed on site. So it's a cost and times savings for the contractors when they're actually constructing. Now, we didn't do this on the I-4 project, but we have done it on some other large Central Florida projects. So on the left-hand side of this aerial view, this is all, I think, 66 or 72-inch pipe. These are 50-foot sections of pipe, and each one of those sections was manufactured on site by the mobile mill in the red circle in this aerial view. So you can imagine all of that pipe being loaded on trucks and being brought to this site, and the extra maintenance of traffic headaches that can bring. We dramatically reduced that by simply manufacturing this pipe there in the red circle and simplifying the installation complexity for this contractor. So in summary, Contech has done a lot of large public infrastructure projects, and I participated in a lot of them. I think we're uniquely situated because of all of the product solutions that we offer. We can satisfy almost any permitting demand that you might have seen, and we can fit within almost any site constraint that you've seen. And backing up all of those product solutions is unmatched design experience. We have just behind the people that you've seen presenting here, a full design team that are designing every day these types of systems, and we've gotten very efficient at backing up what we give you and helping you solve your problems. And with that, I'm done, and I will turn the presentation back over to Jeff again.
All right, Chris, thank you. So yeah, just one final point on Chris's projects that you may or may not have picked up on is that in those two projects, all three different materials that Contech can provide for detention were represented, and that's metal, plastic, and concrete. So the versatility that we offer is really unmatched in the industry on that, in that perspective. So I won't spend much time on this slide. In the interest of time, I want to get to a few questions. But in addition to the best resources that we have, that you just, 4 of which you just heard of, and in addition to our design team that backs all of our field team up, we do have some resources online. Please feel free to check this out. We encourage you to go to the Contech Design Suite, go get some PDH credits if you're in need of those, and then check out some of our certified maintenance providers, which we personally, Contech will certify to maintain all of our systems. Jill, I think we'll turn it over to you.
That's right. If you have a question, type it in the box and I will ask it at this time. Our first question is, what is the largest diameter underground detention system Contech can produce?
Yeah, I think I'll answer this one. The answer to that question is more interesting than you might think it is. The diameter that we can produce is more dictated by what we can ship. So I think the maximum load that we can put on a truck is a 14-foot wide diameter pipe, even with special permits. And we have actually manufactured that diameter before. I'm told that the largest pipe that we've produced out in one of our California plants was 171 inches, which works out to almost exactly 14 feet. And obviously we can manufacture every diameter below that in 1-inch increments. So it adds to that product capability that I mentioned earlier.
Thank you, Chris. Our next question is, why is a smaller manifold preferred?
I'll jump on that one. So yeah, smaller manifolds are preferred. Just a lot of it is for shipping purposes, because if you can imagine, you have big diameter T's and elbows that need to be shipped down the road. That's actually larger than the pipe barrel itself. And then also just from a time of manufacturing standpoint, we can manufacture the smaller diameter manifolds faster than we can the large diameter.
Thank you, Jeff. Our next one's for you, Yelena. A question on project number 1. I thought there was high groundwater for that site. How was storage volume separated from the perforated and the rock backfill void space?
Tell me, can you say that again? I'm sorry. So I think if I understood that, there was a high groundwater, but we were able, by using a smaller diameter, to kind of lift it out of that. So if you remember me saying it had almost 20 feet from rim to the bottom. That project was far more complex. There was no way to say it all in 10 minutes, but we basically brought it up to avoid a high groundwater. And then we had pipe, we had rock, and it was completely wrapped in impermeable liner. So that's how we achieve the separation, if I understood the question correctly.
Thank you, Yelena. Our next question is, what is the tool to be used for detention design on the Contech website?
What is the tool to be used? Contech, the design your own detention system tool?
I think that's what they were looking
Okay.
for. Yep. So
Yep.
we have a whole
Okay.
section on our website. You can design your own detention system, you can design your own other things. So just go to the website and everyone can check that one out. I think we have time for a couple more questions. Is using crushed stone for additional storage void space generally a cost increase or decrease as compared to similar storage volume in pipe only with standard soil backfill?
I can take that one. I mean, it will generally depend on, like, you know, there's all kinds of different factors, but it will depend on geography too and how expensive the crushed rock is. For us, it usually makes sense here in the Northwest because it does reduce the footprint of the CMP. So, but again, we can play with that if you end up going into the design center, you can play with different depths, like 6 inches, a foot, the distance between the rock in between, and that will all help reduce the CMP footprint. So we look at all kinds of options. We usually run, you know, half a dozen options for any of them to see if it makes sense.
Thank you, Yana. Our next question is, how do you decide whether to recommend metal, concrete, or plastic detention materials?
I'll take this one. So really it just becomes a function of depth most of the time. So looking at each depth profile that you have, a lot of these projects, even if they were slightly shallower, we can do something like arch pipe or perforated CMP, but depth really dictates what's going to be the most cost-effective solution, but also requirements. And so like looking at, if you do actually want a concrete system, we might go with something like Terry Arch. If you want a plastic option, we could look at Chamber Max. So a lot of it boils down to preference on what you want to look at, but really depth, again, to try and minimize that footprint size, it does have a lot of impact on what material we would select.
Thank you, Dana. And our final question, with regards to maintenance of the system, what are your recommendations?
I can take this.
Okay.
So for maintaining detention systems, we usually put a full diameter, or sorry, a minimum 24-inch riser. So you can get physical access to inspect as well as maintain it, not just a clean out port, but you can physically get inside. I would recommend pre-treatment, to be perfectly honest. I mean, anything you can do to minimize trying to clean out a pipe system is going to make it easier to clean the pipe system. But obviously, if there is sediment going in there, even with a perforated system, it's still a solid bottom. So you can either jet and vac, you can scoop and shovel. I mean, there's a few different ways to handle it. And we've got a whole maintenance manual that explains that if that's an interested point. You can dig into at a later date.
Well, thank you, Josh. And just a quick note, check the chat box. I popped up the registration links for our upcoming webinars. We have one coming up in April and one in May. If your question was not answered, a Contech representative will reach out to you with a response. A survey will appear once we conclude the webinar. Please complete the short survey to receive your PDH credit. A follow-up email will be sent by the end of the day that will include a link with instructions on how to download your PDH certificate. Thank you, Josh, Chris, Yelena, Dana, and Jeff. And thank you everyone for joining us for today's webinar. Have a great day.